Okay, so what I want you to do is create a popsicle stick. It looks like that. PTV. Perfect. PTV. Simple activity. Straightforward. I feel like we're going to crush this. Appreciate it. Thank you. All right. PTV. Everybody got that done? So let's check out what in the world is this? Looks pretty straightforward, right? PTV. We are looking at how each variable affects the other one. How does temperature affect pressure? How does pressure affect volume? Okay? When you hold one of them constant, you got to hold something constant. Okay? It's just how you can determine other values. Okay? So, let's try an example here. Let's try an example. You decide to make a balloon animal. Anybody ever try that? Yeah, it's always fun. So you're making a balloon animal. As the balloon is being twisted, that's what you're doing. It increased pressure inside the balloon. What happens to the volume? Okay, so if we think about this, I'm going to have my PTV stick, right? Here's my PTV stick. Okay, what in this question is constant? What in this question is constant? Well, we know we're solving for volume. We know volume is not constant. That's not what we're looking for. So which of these two is constant in this problem? Pressure's constant? No? Temperature's constant? Yeah, if you twist a balloon here, you're at room temperature, and if you start to twist it, it's still at room temperature. So temperature is actually our constant. Temperatures are constant. So what you guys are going to do in this simple activity is you're going to put your finger on the T. Or for me, I'm going to put my hand on the T. Okay. When the problem says the increase in pressure, so what you're going to do is you're going to push pressure up. Right? It increases the pressure. You're going to push pressure up. What happened to the volume?
It went down.
It went down. You're exactly correct. You're exactly correct. So when you do it, the volume, and when pressure increases, the volume decreased. You guys see that? Okay. Hopefully you guys see that. Let's try another one. Okay. On a cold winter day, you go to the store to buy balloons for your best friend for his or her birthday. When you leave the store, what happens to the volume of the balloons? Okay, once again, you got a PTV stick. PTV. All right, so what happens to the volume? I'm solving for this. So which one of these is constant? Volume's what we're solving for. We don't know what that is. It'd be pressure. Why'd you say pressure?
Well, because it's asking, when you go outside, the temperature changes. So
The temperature's going to change, right? It's a winter day. You're in here, it's room temperature. You go outside, it's going to be 20 degrees cold. Or negative 20. We're in Ohio, you never know. Okay, so pressure is the one you're going to hold on to. Okay? What happens to the temperature when you go outside? temperature is going to go down. So when temperature goes down, what's your volume do? It also goes down. You guys see that? When temperature goes down, volume will also go down. Starting to see a little trend. So that's what the PTV sticks are. I want you to try a few on your own, just a few, and we'll get into the activity. Increase or decrease? Let's see. Your parents decide that it's time for you to go visit your grandma, who lives an hour away. When you get in her house, you check the tires and notice, what about their pressure? Good.
I'm done.
Oh, you're all done. I thought you had it. I was like, I'm ready.
No, I'm not that smart.
What do we got?
Increase.
Increase.
Yeah.
How'd you get that?
The heat from driving on the road.
The heat from driving on the road, right? Okay, so the temperature increased. We get our PTV stick. PTV stick. If the temperature, so what was held constant here? Volume. Very good. Volume's held constant, so you're going to put your hand on volume. Temperature as you're driving increased, which makes the pressure also increase. Next one. Somebody who hasn't answered yet. Dawson, what do we got?
Is it decrease?
Decrease. How'd you get that?
Because the pressure is decreasing.
Okay, so I got PTV. What was constant here?
The pressure.
Pressure was constant, so that's where you held your hand?
Yeah.
Okay. And then, what's our problem say? What's changing?
The volume.
We're solving for what happens to the volume. What changes, though?
The pressure. Right.
So pressure changes. Does that mean temperature is constant?
Yeah.
Okay, so temperature is constant. So let's put our hand here. What happens to the pressure?
It increases. Yeah, sorry. Decrease.
Okay, so pressure's decreasing. If that goes down, what's volume doing?
Increasing.
Volume's increasing. Increasing. So you had the correct answer. You had the correct answer. Okay, let's try it. Two more. Somebody else. The pressure decreases as a scuba diver ascends to the surface of the water. What happens to the volume in his lungs? Increases. All right, it increases. Oh. You didn't see that, did you? It decreases. All right, we'll go to this one. All right, last one. When you press down the trigger on a can of spray paint, you are adding pressure. What happens to the volume inside the can? Decreases. Okay. So hopefully you notice our PTV stick. If you add pressure, you add to this side of the stick, the volume on this side of the stick has to go down. You guys kind of see that? Hopefully that's a decent visual to kind of stick in your head a little bit. You know what's crazy? Going back to this. Oh, we skipped a few. Oh, no. Going the wrong way. Scuba diving. Do you know that they can only come up 10 meters at a time? It's one of the, I don't call it a fallacy, but a fallacy that movies portray, right? Movies show you people just like go from the bottom of the ocean straight to the top. Why couldn't you do that?
Too much blood pressure to see.
Too much change in pressure. Yeah, your blood vessels will just pop. You'll die instantly. That's crazy. Crazy to think about. Instant death. It is. So when you go every 10 meters is what they say. So if here's the top of the ocean, you go down 10 meters. I think you got to wait I think it's 10 meters every 10 minutes. So you got to wait there 10 minutes. Then you can go down another 10 meters. Which 10 meters is actually a decent amount. 10 meters probably here to that wall. So you're going down a decent amount, but you got to go down every 10 minutes. It's kind of crazy to think about. Crazy to think about. Anyway, so today, we're going to be applying this information. We're going to be applying PTV, our PTV sticks. Okay? What I have planned is we're going to do there's a lot of labs with this chapter actually. So we're gonna do 2 activities tomorrow. Pretty awesome, actually. I'm pretty stoked about it. And then probably do a few on Monday. We'll see. Need to pick up some supplies. Need to do a Kroger run this weekend. Okay. So, or Costco. Costco's my backup. What I did was with the remaining time. In Google Classroom, let's go to first period, classwork, ideal gas. I posted an assignment on Google Doc. Okay? And it literally is what we just went over, the PTV sticks. Okay? But it gives you a visual of how pressure, and I added the link and everything. Oh. What is this? Maybe I didn't add the link. Alright, we'll just have to follow these steps. We'll do vet. Play with Sims is what the next one said. We'll go to chemistry. Heat and thermo. Oh. There it is. Oh, that was pretty easy. Okay. So click on gas properties. Now, we're going to do ideal gases because that's what we've been kind of talking about. Now, you can hold different things constant, okay? You can change the pressure and volume. You can add heat down here. You can cool it down. You can add particles by pumping them in. You're going to add as much particles as you can. But as you see, when you add more particles, what's happening to my pressure gauge up here? It's going up, right? When you release the top, what's happening to my pressure now? Pressure's going down, right? And if you heat it up, what you notice still now? Still going down. That's pretty crazy. Pretty crazy. Right? You can pause it at any point. All right. And there's a few questions that go along with it. All right. So explain how volume, and it says graph. Explain what a volume pressure graph looks like. But mainly, as all I want to hear is, as the volume, let's say, increases, what happens to the pressure? So all I want here is, as the volume increased, what happens to pressure? Volume increases? Decreases? What'd you say?
Does it increase?
Well, hold your finger on the temperature. If V goes up, what happens to P?
Down.
P goes down. So that, guys, this is all I want right here. can type this in right here. Let me highlight that. We'll go green. That's all I'm looking for, like right here. You don't have to answer the graphs. Graphs, it's kind of hard. I didn't print it off. I'm trying to save a little paper, you know. So all I want right here is just to describe it. You do not have to do the graphs. Okay. Make your predictions. If you want to do the graphs, they're pretty straightforward. All right. So try this out. We got about 15 minutes left. If you guys have questions, let me know.